Thank you everyone for coming here today. We are very happy to have Devin Iniski, a research assistant in Dr. Jeremy Kaplan's lab, sharing his work with us. The talk is titled Semantic. Sorry, can you please go back? Thank you so much. Titled Semantic Factor Analysis, Creating and Analyzing Psychometric Scales Using LLMs Instead of Humans. Please join me to welcome Devin.
Okay, so yeah, that's the name. I'm going to start off with a quote. This is weird. So this is from Galton in 1884. So the most important individual differences in human transactions will come to be encoded as single terms in some or all of the world's languages. So interesting. Personality encoded in language. That's the idea here. So here's our outline. First, we'll start off with what is meaning. It's a Christmas talk, so we're going to start off philosophical, obviously. And then, how is that represented in LLMs? Then, to what are constructs? And finally, you'll understand the idea behind semantic vector analysis. So, first, what the heck is meaning? There's a few theories. I'll go over just a couple of them. So, first is mental theory, which is attributed to Socrates. And he said that meaning is the internal mental representation that is associated with a word. So just the idea in your head, the image that you have in your mind. So the issue with that, though, is we cannot study that or verify it scientifically. And then 2,000 years later, Chomsky said the same thing, basically, where he defined it as a non-linguistic concept, which is the same thing. It's an idea in your head. You can't really study that. Then a bit later, we have referential theory. So meaning is the thing that it's referring to, which is circular. You can't really, again, study that very well. And then next we have behavioral theory, which is just meaning is the thing that is attached to a stimuli. So you see someone say that's a cat, and eventually learn that's a cat because it's a stimulus response pattern. And then later on we have Wittgenstein, who came up with use theory, and he said that meaning is the pattern of words used within a language. So meaning is use. Again, this is closer to being studyable, but not quite. And finally, we have this guy here. I don't know how to pronounce his name, but he said that meaning is co-occurrence. So that can be studied mathematically. You can make a model, a statistical model, to study meaning word co-occurrence. And so that's what we have here. And this is the foundation behind a lot of word embedding models, including large language models. So you might be wondering, how can we infer meaning from co-occurrence? So suppose someone came up to you and told you this. You look more lugubrious than usual. You might think like, I don't know what that means. And then they hand you a nice co-occurrence matrix right here. So they give you this. And from this you can see that lugubrious is more correlated with sad than it is happy. And from that you can infer, roughly, that lugubrious has something more to do with sad than happy. And so you can infer meaning from co-occurrence, just like this. And that's the actual definition. So from that, yeah, lugubrious means sad, effectively.
Is this resonating with you now, Norman?
And so this process of inferring meaning from co-occurrence is how large language models learn how to understand meaning. So they do the exact same process, just a trillion times. So suppose a model has these arbitrary initial values for lugubrious, which correspond to sad, happy, and lugubrious. And then during training, the LLM is given a series of input text, and its task is to predict which word comes next. So in this case, he looks so lugubrious. I bet that divorce is making him blank. So suppose the correct word answer is sad, but a guess is happy. In that case, it would adjust its weight for happy to make it lower. It lowers the co-occurrence value. And suppose you have another sentence. He looks so lugubrious. I bet that cancer diagnosis is making him blank. The correct word is sad, and the model guesses sad. And in that case, it increases the co-occurrence value for the sad dimension. And in this pattern, basically, it learns through co-occurrence meaning. And you can also look at it this way too. In order to get good at predicting words, you have to understand what they mean. That's just part of the training. Your goal is to predict words. So to do that, you happen to understand meaning. and that's large language models. With a few exceptions. First of all, in reality, the vectors for each word are not 3 dimensions, like I have this example, but they're actually thousands of dimensions. And also, these concepts are not just single dimensions, they're most likely combinations of dimensions. So for example, stat could be like a combination of 3 different dimensions or 100 different dimensions. As well, most combinations of dimensions correspond to concepts we have that don't actually exist in our language. For example, I have here, there could be a dimension that exists that represents the feeling you get when you open the fridge. When you open the fridge again, even if nothing has changed. So it's just like English lugubriousness, basically, where you open the fridge and nothing has changed. So again, imagine this example, but much longer and much more complex because of the combinations of dimensions. So we can do some quick math here. The model I'm going to use in this talk has 4,096 dimensions. So if you assume that concepts correspond to, each dimension corresponds to 10 concepts, then the model will contain 10 to 29 concepts, which is way more than atoms and meters. And it's even more. So if each dimension corresponds to 100 concepts, then the model will contain 10 to 204 concepts, which is way more than atoms in the universe. So basically, these models likely contain trillions of concepts, which is really crazy. Yes.
What do you mean if each dimension has 10 vector values or 100 vector values?
You could say that too, yeah. Mine is still correct though, is it not?
It's confusing to say it corresponds to 10 concepts, because usually we would say each concept corresponds to multiple values in the vector. So, to me that's clear. Right?
Okay.
That's what you wanted to say? Good.
Yeah.
Continue. Thank you.
So next we're going to pivot to psychometrics real quick. So what is psychometrics? Metric means to measure, obviously. So psychometrics is the measurement of constructs. What are constructs? There's a few theories, only 2 this time, I'm going to give you 6. Once again, mental theory, it's the thing in your head. That's how they define it here. You can't study it, obviously. We have operational theory, which a lot of people use still. The construct is how you define it in your procedure. So you see that sometimes still. The problem with that is that you can't. It's subjective and also instrument dependent. So you can't study a construct of similarity. So if there's like 100 different definitions of depression, for example, you can't study that as a unified thing if there's different definitions. But then we have nomological network theory from Korbach and Meal, which says that constructs are defined by patterns of lawful relations with other constructs, theories, and observations. In other words, co-occurrences. So here, constructs are being defined as co-occurrences. And that makes it compatible with psychometrics. So depression is a single thing that just co-occurs. It also makes it compatible with clinical psychology too, because like the DSM, for example, depression is just a set of co-occurring symptoms. So it's all related. What does this slide say? So basically the idea behind semantic factor analysis is, does the distributional theory of meaning approximate the nomological network of constructs? So if constructs are patterns of co-occurrence, like symptoms, for example, in depression, then will that be captured by the co-occurrence of language? And that is a basic idea of semantic factor analysis. And now to explain semantic factor analysis, I'm going to compare it to traditional factor analysis. So in traditional factor analysis, if you're not familiar, you create a scale. In this case, name of the scale in Westbury's class last semester or last year on procrastination. So it's a list of items that helps to measure procrastination. And the question you ask with factor analysis is this construct one-dimensional, so it's just procrastination, or does it have subcomponents? And so you get human response data, so you give a bunch of people, and they respond to it. So in this case, it was 1 to 9 for each item. And you identify with factor analysis whether groups of items correlate with each other. So factors are clusters of correlations. So I'll show this example later. So in this case, this is the result. So this is a factor loading plot. So you get the latent variable, which is the cluster of correlations. That's a new variable. And you correlate that with each item. And you see here that half the items in this case correlate with this one latent variable, and half the items correlate with this other latent variable. So there's two clusters of correlations in this scale, which means there's two subcomponents for procrastination. Yeah. So this is how it was divided. It just happened to be the case that exactly half the factors or items were one factor and this is another factor. So it splits very nicely in this case, which is convenient. You can so then the next step here is conventionally you look at these items and you use your human judgment to name each factor. So this is all procrastination, but there's two components. What are they? You look at these items and you just make a name. You use your expert judgment. But that is subjective. So we have a better way, which is called semantic factor analysis. That's the wrong way. Okay. So in SFA, you have the same scale you start off with. In this case, you take each item and you code it into an LLM. And so this is the meaning vector of each item. It represents the meaning of it. In this case, we used this modern model, which is a cloud-correct model for this task. So it's the best one you can use at the moment. And again, it has 4,000-dimensional embeddings. So again, you take each item, you convert it into a meaning vector, and then you perform factor analysis on that meaning vector. So again, we're comparing just the human data and the LLM data. So each one has items as rows, but with the human data, you have each participant respond, think of a value for each item. And with the LLM, you have each dimension which corresponds to concepts or combinations of concepts in high-dimensional space. So you do factor analysis on that to identify clusters of correlations of meanings, or clusters of meanings, basically. And this is one of the results. So for procrastination, there's two colored dots, and therefore two clusters. And so this plot has to be explained. This is a TSNE plot, which stands for T-distributed stochastic neighbor embeddings. So basically, we have these embeddings. There are 4,000 dimensional spaces, so 4,000 dimensions. I'm going to graph that onto 2 dimensions. And so that's what TSNE does. So in the original space of 4,000 dimensions, you assign probabilities at each point, for each pair of points. So nearby pairs get assigned a high probability of being related, and far points get assigned a low probability. Then you place them at a randomly across the 2D space, and you use gradient descent to move the points that have a high probability closer together, and the points that have a low probability farther apart. And so it's just a way to map high D spaces to 2D space and graph it. So we can look at it with our human brains and use the T-distribution, so just as a parameter. And so the way you interpret it is that the clusters are preserved, but not the true distances. So you can't measure the distance between two items or 2 points to interpret it. But the clusters are preserved, and that's what we want to look at in this case, so it's useful for us. So in this case, we see 2 clusters. And again, so you might wonder why there's 2 points at the bottom here that are from this color. Just imagine you have a map of the world that's 2D, and in that case, on one side is North America, and the other side is Russia. Even though in reality they're actually close together, it's just a limitation of mapping down high D spaces to low D spaces. So if you imagine a globe, obviously they'd be connected. So just artifacts like that cause these things. If you imagine it's wrapped around itself, these points would be next to there, for example. So the clusters are still preserved, it's just the way it maps it down to living spaces. It tries its best, but it's not perfect. Anyways, so we take the scale, we have the meaning vectors, we see if they are similar to each other, and then so we have these clusters of meaning, so each one is a cluster of items that mean similar things, so there are 2 factors of meaning. What we can do now is get the average meaning of each cluster, each factor, and assign a label to it. So that's what we do in the next step. So again, we use another really big model that's really good at naming stuff. So you get the average of each factor, and that represents the shared meaning of the group. And then you identify 10 words that are most similar to that average meaning, and you feed that to a encoder LLM. So you actually just give it this right here. Given these 10 words that represent the average meaning of each factor, make a label. And it does that.
Wow.
And so basically it's a way to name factors deterministically. So let me drink some water first. You might be asking though, why can't we just take the closest to one word near the center of each group? And that's because to make the meaning vectors, we use an encoder LLM, which goes from text to vectors to meaning. But to make labels, we need a decoder LLM, which goes from the labels or for vectors to text. And so we have to somehow carry over that meaning from the encoder LLM to the decoder LLM. And the best way I found to do that was to use 10 words. And that kind of captures, again, the average meaning of each cluster and allows you to take over to the decoder LLM to make a label. Yeah, let's see. And again, as well, if you just did like a nearest word search, a nearest single word search to that label, it'd be limited to one word, even though you could reasonably expect factors to be more than one word. It could be 2 words or even maybe 3 words, and that's the other issue here. So, this is our whole process.
So the centroid is not actually a word.
The centroid is the average meaning in dimensional space.
So it could be like in this plot, like in some empty part of semantic space where we don't have a single word in English.
Exactly, yeah.
But then you can
so it
kind
finds
of
the nearest word.
get to it with a weighting of a bunch of words, and then puts you back at that point.
Correct, yes. It's like the nearest human word to what we have for each cluster of meaning. So the key benefit of this approach is that it's deterministic and reproducible. So for a given LLM and a given set of scale items, you always produce the same factor labels. So instead of having subjective debates over which name is correct for the factor, you now have a way to shift the debate from subjective theories to objective parameters in a model, which makes it less objective, and also you can test out new scales without using human participants. So this is just using LLMs. There's no humans involved in this process. So you can again test out psychometric scales with just LLMs. And in case you're still confused, I had Gemini make an image of this process. So you have your well-known, you have your encoder LLM right here. You have, I think that's your data right there, and that's the brain. And you got some well-known factors. You got depression, you got anxiety, and also well-being. So we all know those words. Just a funny example. So of course we're all wondering, does this actually work? Is he crazy? And the answer is yes to both of them. So here's my data sources, first of all. I found like a lot of open source data for different scales. And first of them is the DAS scale, so depression, anxiety, and stress. It has 42 items and 3 factors, depression, anxiety, and stress, believe it or not. So what I'm going to show this data is going to show a correlation plot. Oh wait, no, first I'm going to show the items. So those are the depression items, they have depression content in them, pretty self-explanatory. Anxiety, stuff like I felt terrified, I was close to panic. And stress, I was irritable, found it hard to wind down, and so on. Okay, now we're at the correlation plots. This is the human data. And as you see, we have each item here and their values, they're like human ratings, correlated with each other item here. So it's a correlation plot of all the items. And you can see there's 3 clusters of correlations, and that's what factors are. So here, we expected 3 factors, and we found 3 factors in the data. There's 3 clusters of correlations. And so that's the twin factor analysis. Now we'll compare that to the LLM process. In this case, we're comparing the meanings of each item and the meanings of all the other items in the same way. And this is, wrong direction, and this is that plot. This projector is kind of mid, but you can see, again, there's 3 clusters of correlations. So not only does it capture the global structure, but also, if you look, I have a laser pointer, don't I? Ooh, you can capture the local details too. So like this little group here is also found there. It's hard to see because it's not the projector, but you can look at these ones here are also found here, and so on. So it captures even the local details the same way that human responses do. and which is really cool. And I'll show this.
Is it overall finding more similarity though across the items?
It is, yeah, it is darker overall.
Yeah.
And so yes, items are more similar on average compared to the human response correlations. This makes sense. This is like the idea here makes sense. So we're comparing human responses and meanings. And essentially we're doing correlations of each. And now as TS&E plots, you can show clusters that way too. In responses, we have a depression category, stress and anxiety, and the same thing with the LM data, depression, anxiety, stress. Except in this case, here's the names that came up with. So we have despair, anxiety, and irritability, which those make sense. It's not the exact same, but it makes sense. And so, what this is saying for the despair example, in this case, the word despair was closer in meaning than the word depression was. Like, it could have chose depression as the label, but instead the word despair was closer in meaning, average meaning, to the factor cluster, which is principled, and again, it makes sense. These aren't like random names. Also cool is that both have, in this case, depression is like a very isolated cluster. It's like very far away, whereas anxiety and stress are kind of intertwined. And you see that here too with the LM data. So it captures also the ambiguities in the scale, not just the separations. And even the individual items too overlap. So A20 is like in the middle for both of them here, as well as a few other ones too, A36 and so on. So again, it captures both the global details, the clusters, as well as the ambiguities. So it replicates it very well. And I should also point out too, these labels here, so D and S and A, are from the original scale. So those are the expected labels we have from how the scale is designed. And so even here you can see that in the stress cluster, there are some anxiety items, and for the anxiety cluster, there are some stress items too. So neither the human factor analysis or this SFA perfectly captured or distinguished the structure. So again, there's ambiguities in the scale that was captured by both methods. So in this example worked very well. This is a really clean example, but not all of them are like that, obviously. I'm not going to show you all the good examples and not leave the bad ones out. So next is a bad example. Actually, now first is this question. So I might be wondering, are larger models better than smaller models? And the answer is yes. So you can define a factor separation ratio as the within factor clustering divided by the between factor clustering. And to do that, and we have these numbers here. So this is a very small model, which has 0.6 billion parameters, and that's its ratio. As you go to 4 billion and 8 billion, you have a better separation between and within factors. So the idea here is that larger models do understand meaning better than smaller models, and you see that here in the separation ratios. So larger models are better, which you kind of expect, but now it's quantified. But neither are good as the human response data, which is a bit higher ratio. Next is the big five.
Excuse me, will it change with another trillion words? I mean, as these models get bigger and bigger and bigger, will they approximate more closely to human data, do you think?
I mean, that is the trend.
Or does it asymptote?
I mean, that assumes that all the variance and the LM embeddings are explained by, or all the correlations in the human data is explained by semantics, which might not be the case. So it might never fully approximate. So does that answer your question, or can I elaborate on that?
It's good enough for me.
Okay.
There's something else, that's what you're saying. It could be, like after.
Like there's other factors that influence responses in data than just semantics.
Yeah.
Maybe the participants
Embarrassment or social desirability.
exactly those kind of types of things, yeah, which may influence responses that the model may not capture. The large language model is. So anyways, next is the big five, which has 5 factors: openness, conscientiousness, extroversion, agreeableness, and neuroticism. So how did we do? Not as well. It looks worse on this projector, trust me. It's not that bad. You can still see roughly 5 clusters here, but it's not nearly as well as the human data. And again, we have a large sample size here for the human data too, so it's pretty reliable. And now we go to the TS&E plots, this is the clustering, and not quite. So in this case, the human data has perfect separation for all 5 factors. This is perfect. There's no there's no crossover at all. Whereas with the LLM process, we have 3 factors. So we have creative drive, which is partially conscientiousness, openness, agreeableness, and extroversion, so all 4 of them. Emotional volatility, which is mostly neuroticism and agreeableness, and then detachment, which is all 4 of them again. So not as well. Why might this be? I believe it's because the items in the scale all have very similar sound to them. And so it's capturing that like general semantic noise as in the embeddings when it tries to assess the meaning. So I think that's just one potential way to solve this is to have a psychology-specific large language model that knows psychology better and can better differentiate these meanings. And so we can test this actually because someone made one, kind of. So there's a model called NPNet personality, which was trained on personality text. Even though this paper is published in 2025, the model is actually 5 years old. It's from 2020, so it's a very old model, and it's very small comparatively to modern models, and it's not as good at understanding meaning. So this is not a very good model, but it's the only one we have to use to try and figure this out. So will a personalities just fine-tuned model do better at this task? And here's our correlation plots. As you see, it does a lot better. So if you train it on personality content, it understands personality better. As we see, much better separation. And then the TSNE plots, 6 factors, close. But still, though, it does group quite well. So it does extroversion perfectly. It does agreeableness perfectly as well, neuroticism and conscientiousness. But it's insisting that there's some sort of smaller factor within openness. And those are items 44 and 42. And what are those items? These 2. So it's insisting that these 2 items here are different enough in meaning than the other items in this factor, which, if you look at it, it kind of makes sense. You can kind of see why it's saying that those 2 items are part of conceptual thinking and not openness to experience. Which is just, yeah, it seems to make sense. But yeah, the point is that if we had a psychology fine-tuned model, which we don't currently, like a general one, it might do a lot better than our general LLMs. So that might be another project for me to do is make a psychology model. So it might be a lot better. Yeah. Next is, so now, those are all scales with like many factors in it. How does it do with one factor? So in this case, the factor is just the construct, depression in this case. So we have the depression inventory. One factor is depression. How do we define it? First, let's show the items. Again, they're all involving depression, basically. How does it do? It's hard to tell. There's no global structure. You can see it looks like it's all just a mess. It does replicate some of the finer details, though, which is hard to see, but like, there's like a square of 3 of them here, and it is replicated here. It's harder to see, but that is the thing. So it does capture all the fine details of the scale. Even like these ones here are captured here. So you can't see any factors in it because that's because there is one factor, and that's what we have here. So both of them found one factor. In this case, named it melancholy. Again, it makes sense. It's not depression, but it's arguing that the after meaning of these items in the scale are more like melancholy than depression. So, again, this is reproducible. This is the key point. You can verify with the model's internals. Back in anxiety inventory, one factor is anxiety. Let's see what it does here. First, let's do the items, which are all involving just words that are related to anxiety. It's from a 1 to 3 scale. And yeah. Again, no clear 2 factors that argue. Both are just pretty noisy, and it replicates, again, a lot of the individual correlations here. When it's the darkest. There's also like this group here matches this group there, and so on. So it captures the smaller details. And let's look at the factors now. In both cases, 2 factors. And I named them anxiety, which is good. You want to see that. Pretty logical, and also physical discomfort. So, yeah, the fact that both have found 2 factors is interesting. And it's also roughly the same items that are in each set of factors. In this case, the light blue here is actually the dark blue here, and the other way around. But again, they're roughly from the same two factors. And in this case, you have no clue to call this one because you can make up a name, but in this case, you have a way to make a deterministic name, which is, in this case, physical discomfort. And we can look at the items too in this case. So these ones are physical discomfort, and the rest are anxiety. And if you look at them, I think that makes a lot of sense. They all involve physical discomfort. Hang on just for a bit, you can read them. You might argue too that hands trembling should be part of physical discomfort, like kind of would seem like that. But if you go back to the plots, in this case, A12 is actually right on the edge of the physical discomfort. So it's like right between the two, which makes sense. So it captures that too, and A13 involves is shaking, and that one's kind of close too. So it maps meaning quite well. And the more you look at these, the more reasonable they seem. Next, we have the Machiavellianism test, which is 20 items, has one factor, Machiavellianism. You might be wondering what does it actually mean, and we have a definition here. So it's defined by manipulativeness, low empathy, and cynicism. It's named after this political guy from like the 1800s, because his writings involved manipulative behavior. Although the construct is often confused with his ideology, which also has the same name. So as a result, some scholars argue that the name should be changed to something else, something that's more representative of the construct. And so we can do this with a new method. We can make a new name for it. That's what we're going to do here. So here's our correlation plot. No, here's our items first. I keep forgetting. You can read them and get an idea of what the scale actually is about. And results. Again, it captures all of the local details. It's hard to see, but these two here is captured there. And even like these two here are captured here. So again, it captures all of the local details. What's the name? Integrity. So again, both have one factor, which is good. They agree. And in this case, the name came up with integrity. So that makes sense. I guess it's more like lack of integrity, but still, they do involve integrity. So, yeah. This can be useful for naming scales, both new and existing ones, with a principal process. Lastly, we have a few more. The right-wing authoritarianism scale has one factor, which is authoritarianism. And here's some of the items, not all of them. You can see that, here's a good one. There is absolutely nothing wrong with nudist camps. I'm not sure what is that. That's we're going to put in there, but I don't know. I guess that's an anti-authoritarianism.
Yeah, I think it's reverse scored that one.
It must be.
Looks like
Because
the
it's
law
still a funny item to put in there. And so, yeah, they all have to do with authoritarianism. How to do? In the human data, one factor, and in the LLM data, two factors. So it's arguing here that there's two separate concepts in the scale. So one of them is zealous reform, and virtue ethics is the other one. So you might be wondering which is which in the items. And here we go. So apparently nudist counts as part of virtue ethics, which is, I don't know about that. And in case you're not sure about virtue ethics, this is the moral theory that emphasizes character over consequences. So it's just be a good person, basically. And yeah, this is how it thinks the scale should be structured with these two factors.
It looked like the human data had two clusters. Is that?
It did.
Or is that an
I
illusion?
think that's the same thing as the globe analogy. So this is close to that if you look at it that way. It's just the way these plots are made. But yeah,
So that has nothing to do with the two factors that the.
No, those aren't the same. There's no relation between the two. No. I was double checking, but no. So yeah. Next is the moral foundation questionnaire, just a pretty big one. We have 5 factors: norm, care, fairness, reciprocity, in-group and loyalty, authority, respect, and purity, sanctity. How does it do now? Oh, again, here's the items. Here's examples of items, in case you're curious what these actually mean. Because these labels are very, I think, subjective, and they could benefit from a more grounded way to define them. And here's our clusters. Very strange. Kind of confusing. They're very different here. And here's our results. In both cases, they found 2 factors, which is interesting. It's a pretty big sample size too, about 6,000? About 6,000. So even though large sample size, in this case, the human data found 2 factors, and so did the LLM data. So, interesting. For the human data, most of them loaded onto the purity, sanctity, and harm, care factors, which are the first 2. But the LLM data, the names that came up with were moral causeness and virtue, which is interesting. But I don't think it makes a lot of sense. So, yeah. Another question I have is like, is there a correlation between, or what is the correlation between the human responses and the embeddings directly? So, what we're doing here is we correlate each pixel with each pixel. So like, these two correlate, you can correlate these two as well, and so on for the entire triangle. And these are correlations for each. So, it's between like 0.69 and 0.29. And the R squareds are there as well. And so, that could represent, R squared could be thought of as like the proportion of human item response structure explained by semantics, because the model only contains the semantic information of each item of each scale, whereas the human data contains other things like response biases and so on, and other factors. So 0.23 is all right. There's a range of correlations. So you see that generally the higher the correlation is for each scale, the more the factor structures align. So MQ is pretty low and it didn't work out very well. But the DAS worked out very well and has a high correlation. But yeah, so that's also interesting. So what's next? So SFA is a new approach to to examine the structure of scales and their factors without human data, which is cool. It also makes deterministic and reproducible factor names, which is also cool. But there's even more we can do with it, which I haven't gotten to yet, but I'm going to list them here. So you could use this approach, for example, to generate new items. Like, you could just ask ChatGPT to make a list of new items, but you can also use a more principled approach and have, like, you could rank items by their similarity in the construct, or you could, yeah, that's one of the ways. You can also validate existing items, which again, if you have like depression as your construct, and you have a list of items you're considering for a depression scale, you can list how similar each item is to the depression construct, the word depression, and that will be a way to quantify that similarity. And that could be like used as an approach in filtering items. So you pick the top K most similar items, for example, and use those in your scale. And also you can maybe quantify content validity. So this is a very theoretical idea, but I think it has potential. So if you look at those TS&E plots, each factor can be thought of as a shape in high-dimensional space. So if you like connect those points, let me give an example. If you connect all these points, this makes a shape. And that shape is essentially the meaning of the construct in all dimensions, all semantic dimensions. And so suppose you had depression as an example, and you define that shape, and you have a scale that measures depression too, and you also input those scale items into the LLM and get those points in space. The extent to which the scale shape approximates the construct shape could be a measure of conceptuality, which is the extent to which your test measures all aspects of the construct. So that's also something I'm working on as well, is trying to quantify conceptuality. And I was pretty fast actually. I talk very fast, so that makes sense. I was studying slides. Any questions?
I have a comment. I wish I'd said this to you earlier, but I think we should normalize those correlations before we put them side by side, because the problem, the reason they look different is because the correlations in the semantics are much, much higher than the correlations in the human factors.
I think it's
If we just normalize them, then I think we might see more structure. Like we're really interpreting the colors there, and the colors are somewhat arbitrary because they're just showing that we have higher correlations in one than the other. So I think if we normalize them, we might see more structure. That's all I'm saying.
Maybe. Try that.
Worth a try, I think.
Fisher transform too.
We could do that.
You do, but not in the correlation plots.
Elaborate.
Those are ours.
Those are mental tests, so it's not.
Oh,
It's a different kind of R squared.
but it goes from -1 to 1.
Yeah. Because some like reverse code items have the opposite correlation and their values.
Just saying, if you Fisher transform, you can do all sorts of normalization, and it works.
I'll look into that too then.
R values again. And when you correlate the correlation matrix, you should Fisher transform for
Fisher transform them to p values?
Z.
Z values.
Oh yeah, maybe actually.
Because then Z's you can do
Z-scores.
normal things.
Interesting idea.
Yeah, that's a good idea.
Yeah.
Yes.
Super exciting
Thank you.
that you're doing this. I'm still a bit confused though. So the semantic factor analysis tells you something about who constructed the scale, right?
It does,
So
yeah.
it's not about how it matches with human responses. It's the construct of the person formulating the question makes this sense or that sense or whatever. That is what you're picking up with the semantic factor analysis, which may be good or bad, whatever, but it doesn't even have to correlate to human responses. I don't really understand like that link between one versus the other. It's two different things that are doing two different complementary things, right? So I think for constructing new items, it's great, I think, to use this kind of approach, right? Or you would do your own scale as you did, and finding the names, for something that you don't know yet, right? I think this is a great tool, really cool. But to replace humans, this is completely different. Yeah. Or maybe I misunderstood this.
It's not to replace humans. It's to like it's to test with a scale before humans. So like you still use humans in actual scales, obviously, but it's a way to test it out beforehand.
Yeah.
And I mean, you could think that perhaps when a human reads the scale, when they respond to the scale, they might consider the semantics of the scale while they're doing so. So there definitely is a semantic component in the human side of it too, and that's also shown the R squared as well.
Right. But so, for example, you have an example for the BDI, the back anxiety, and so on. This is not meant to be items that belong together in a semantic space at all. These are clinical symptoms that are, arguably garbage together, whatever, but they shouldn't actually behave in that kind of way. Do you know what I mean? They don't. They don't. If you look at the DSM diagnoses, for example, yes? Mm-hmm. Depression symptoms have nothing really to do with each other. They still belong to the clinical syndrome of depression, you see?
I mean, they're so related, but
trying to find a semantic similarity between them, or the, one-dimensional nature of it, fair enough, whatever, but, it doesn't really match. The goal of the scale, of this scale, the back, the PDI, the anxiety survey, the DASS even,
And that's the point too. I think might be related to your point, but like this method is more intended for new scales. Like it makes sense if you don't know that if you build a scale with the fact names in mind, like the DAS, was built in mind with depression, anxiety, and stress.
Yeah.
In that case, it doesn't make as much sense to do this approach. It's more so when you don't know the factor names, like for example
exactly.
the Big Five or
Cool,
or the MFQ. And so that just didn't have much. I just like needed. I was limited by the public data I could find. So
no.
if I had data for other scales that are more.
Also very cool that you found this weirdness in the NeoFFI or whatever the Big Five.
Yeah.
It's super broad. These are the personality questionnaires that apply to all of humanity, right? Like you see replication of those 5 factors across the world, across all languages and cultures and so on. These traits are super broad.
Yeah.
Right? So then the items would also be formulated in this kind of weirdness sense, right? So that you'd have to go to your LLM that was specifically trained in psychological constructs, right?
Yeah.
Because otherwise it makes no sense.
Exactly. Yeah.
It was really cool to see that, actually.
Thank you. Yeah.
Well, I find this really interesting and kind of over my head, but one thing that seems to come out, particularly when we look at the references you've got up there, is that semantics is a moving target. And what you might be picking up here and what might actually be an important contribution of this approach is the fact that like some of those questions are just musty. Like,
PT Barnum.
you know, like the terminology is wrong, and you can kind of pick that up intuitively, but these things have been instituted, and now you might be in the position to say, look, this stuff is off track now, and then you might be able to use this to refine things to update it to the 21st century. So I think that's a really
that's
interesting
a cool thought, actually, yeah.
application.
Interesting. You did like one paper for each scale, get like 10 papers done out of that.
Yeah, go for it, man.
Low hanging fruit. Cool. Any other questions? Yes.
Yeah, I'm just thinking about when you're using a large model, the giant model, like 235 billion, to generate that word. So you can adjust a prompt a little bit to, like, you can think a little bit and produce the answer at the last 1 or 2 words. But don't let it just output the answer, because sometimes, like, if you give some time to think, like give some tokens to think, then it may produce better tokens. Otherwise, like many people are trying especially Chain 1.1, like many people are trying that. It loves to output Chinese. So, if you give it a little bit time to think, it might be better. Yeah.
Interesting. Yeah, I want to keep it as simple as possible and not have it do any thinking or any like. It's like 0 temperature and no thinking. But yeah, maybe you could try thinking.
Yeah,
But it's like more. It's not as like direct in that sense, and have it as direct as possible, so you get like without any hidden stuff going on.
Yeah, the prompt engineers do have a problem, but like based on many summarize, like it's a better way to let it think for a while, the chain of thought.
Interesting.
And yeah. So I mean, for most of the time, the you generate the answer is good, but sometimes like if you give you a better answer if you let it think.
Interesting. Yeah, I think I'll try adding thinking to that, see if it improves the names. It's a good point.
Yeah.
So, 2001, continuing with Syzygy's line of thought, these this thing about when you trained on this personality literature, you got a kind of more sensible factor structure. So I started to think about like, words have multiple meanings and multiple functions in different contexts, but these LLMs can accommodate to a context.
Right.
So I wonder, and then I think that most of these will have a preamble. Like these questions are about blah.
Exactly.
Think about this as you answer them. Think about yourself. If you would like tell the LLM this, give it that text, you could make it its own prompt. Like, this is these questions are about a personality, for instance. That might already help focus the generic large LLM on the kind of factor structure that the small one found. But if you just give the preamble, you might actually reconstruct what the subjects are doing when they answer questions.
Interesting.
It could be worth a try.
I mean, you also brought up another point too, which is that certain items have the same wording at the beginning often, and that's what you see here in the MFQ. So that's
You brought that up.
groups of three are is that they all start with the word whether, and so that is an issue with this approach. Is like again it captures the whole meaning of each item, including the unrelated words. You'd hope that attention filters out those irrelevant words, but it doesn't always do it. In this case, you see that here. So then you might try to think like kind of like remove the unimportant words, just keep the important words, and give that to the LLM. But what I found is it's very hard to objectively find those cutoff points as to what constitutes the core of each item.
Yeah.
And so
But
that's why I just give the whole thing.
Instead, you prepend the preamble and the question. Preamble question. The other thought I had from what Esther was saying was that like, maybe you want to scale that people can't answer based on semantic similarity. So you could kind of invert this and use it to design a questionnaire that shows like a no factor structure or minimizes the correlations across questions to make it more efficient and to prevent why you have reverse scored questions so people don't just like answer the same throughout. There's a whole class of reasons why a participant might get drawn into the wording of the questions and maybe they're answering less introspectively the way you want them to. So like inverting this and trying to get rid of the LLMs.
Yeah.
So the LLM makes the LLM unable to find the factor structure that then rules out semantic similarity of the questions themselves as an account of how humans are responding. And then the human factor structure is kind of more valid in that sense.
That's true as well, yeah.
Chris disagrees, I think.
I do disagree, yeah.
Yeah.
If you have an instrument where everything is uncorrelated, that instrument is not about anything.
No, but if it's correlated in the human responses, but not according to the
It's correlated in
LLM.
the human responses, but not in the semantics. Yeah.
But do you think everything is in semantic space?
Well, I think anything that we think exists as a construct is probably captured in semantic space. Like I don't entirely agree with everything that Esther said. I agree because depression is a construct, and it's a construct in part from observing human beings. And we all know that depressed people cry and they can't sleep and they can't eat. And people talk about depressed people that way, even in non-clinical settings and in novels when they're sad. I couldn't sleep, I was crying all the time. So these things come out, I think, even if they're real, if there really is something there, they should come out from the semantics too. If there isn't, I mean, if they don't come out from the semantics at all, then I think you can question whether there's actually a construct there, which is, I think, one of the benefits of doing this. It allows you to look and say, is this construct really solid? I think the correlation that you showed was interesting for that reason, because it kind of allows you to say, how solid is this instrument? When you say how much is the semantics capturing of the human responses, well, in the ideal case, I think they should be very high. And some of them are very, very low, and some of the ones that are very low are kind of fuzzy, difficult constructs, like Machiavellianism.
Just to add, people with major depression can have non-overlapping.
Of course, totally
Just
right.
saying,
Yes, totally right.
So I
It's like-
think this applies better to psychological constructs that are meant to be measured with multiple different similarly sounding things.
People can have
But
non-overlapping
I
symptoms,
think,
but the instrument was made with all those symptoms because they're part of that family for that construct,
part
right?
of the clinical picture,
Yeah,
but
part
not
of-
necessarily semantically related.
Yeah, but I'm saying the clinical picture would be captured by the semantics if it's a real relationship.
I don't think so. But,
Okay.
That was fun to watch.
So
I can't decide. I agree with both sides.
to me, seems like I think I agree with Esther said. LLM seems like a designer point of view. So when I design the skills, I try to make that different or similar. But when participants make a response, the correlation really measure depend on the individual differences. I don't think the LLM can catch anything about individual differences. So
Right.
this is a reason if it is orthogonal at the beginning, of course orthogonal. I mean, design point of view is orthogonal. Response point of view also orthogonal. But if it is not orthogonal, I don't think this has any relationship at all because you don't know the individual differences at all.
But you don't know that from ordinary factor analysis either. There's nothing about individual differences in ordinary factor analysis.
Well, then get external validity, right? I mean, you have the
You can try different LLMs.
Well, yeah,
Just
yeah,
as
that's true.
and you can try different LLMs. Just as what I'm doing now.
Right,
Just
right.
Or have all of them, yeah. Just use a bunch of LLMs as like your participants and see if they agree or like the most common name they come up with.
Yeah.
I'd also consider that, but I haven't tried it yet. But that's on my list of things to try is having like a whole council of LLMs.
Because
Yeah, I'm trying a little bit like Llama, Chenwen, and the Minstrel and
Yeah,
Jama.
one of each.
Yeah, one of each. And yeah, it gets interesting answers. Like every LLM is doing different things. They're understanding things differently. Yeah, that's why I call like analysis for individual differences. Yeah.
So I don't think the individual differences are all about our understanding of the meaning. It's about our if we have any issue or not, right?
Okay.
It's a psychological thing. It's totally not a semantical.
But that
I
might be
think you're
captured in
talking about
semantics.
using the actual instrument on one person, right? That gives us individual differences. This is all about trying to decide whether the instrument is actually doing what it's supposed to do. But yeah, you can give someone a depression instrument and say, you're not depressed. You can give it to someone else and say, you are depressed. Like, that's individual differences, that's what you get them.
Yeah.
Yes. So if two items totally different semantically, but humans respond totally the same for one of them, the correlation will be 0. You are not measured individual differences, right?
Between one item and an item.
Okay,
that's
so two
correlated
items
with?
maybe not orthogonal in semantic space. And then human respond to one item totally identical. We're not sensitive to that. No individual difference. So then the correlation will be 0.
Between two items, or are you talking about two individual items?
Yeah, I think all the stuff is just many items, but if we just think about two items.
Nobody would make an instrument that had two items on it. But
That's just one bigger case, easy to understand.
No.
I think you're talking about bad items, right? If you have an item that is not correlated with any of the other items on your instrument, that's a problem.
What I'm seeing, the LLM cannot tell us individual difference about human.
No, it's not. No, it doesn't
Traditional
say individual differences. No, I agree with that. Yeah. It can tell you something about whether the instrument you're going to use to look at individual differences is good or not, but it doesn't tell you the individual differences.
I think that the reason is this one is different from this one because this one is captured by the individual differences. This one has nothing to do with individual differences.
Of course, one of the points is they're often the same, right? Sometimes they're not, sometimes they are, but sometimes they are very similar to each other.
Yeah.
It's pretty
Yeah.
informational and also very interesting.
Yeah.
Yeah.